Non-traditional machining part 5. So in this lecture, which probably is the last lecture on the conventional machining methods, we'll be discussing about shaping, planing, broaching and hobbing. I am Dr. Gurraj Singh. So we'll be talking about shaping, then planing, followed by broaching, and finally concluding by hobbing. Now when we talk about shaping and planing, they are usually discussed together. And why is that so? Because they are similar processes. They have their own similarities, because both of them, they use a single point cutting tool, and in both of these processes the cutting is done using the reciprocation of either the tool or the workpiece. So both shaping and planing, they are the conventional machining methods that follow subtractive manufacturing. None of them utilize any rotational motion, and only the reciprocation is used. So only reciprocative motion is used in both these processes. Now if you take a look at this image, you see that both the processes, they seem pretty similar. You have a single point cutting tool in shaping as well as planing, and you've got the same reciprocating linear motion in shaping as well as in planing. But the difference is that in case of your shaping process, it is the tool that is moving, and in case of planing, it is the workpiece that is moving. So that is the basic difference between shaping and planing. The areas of application of both these processes, they are also similar. So they're used for making grooves, slots, pockets, etc. Now on to the left is a shaping machine, and on to the right is a planer machine. And these are the different types of shapes which can be made using both shaping or planing. You can make grooves, you can make slots, pockets, etc. In both cases, excess material is removed from the workpiece in the form of chips. So therefore, you are removing it in the form of chips, unlike ions or atoms or solid debris that we are doing in case of the non-conventional methods. Shaping and planing has material removal just like in case of any other conventional process like turning or milling. They both utilize a single point cutting tool, so they have a single point cutting tool that is used. So we've already seen that. And a quick return mechanism is employed in both the machine tools, however their point of application are different. So what do you mean by a quick return mechanism? This is a quick return mechanism, a Whitworth's quick return mechanism. And as you see here, you have this mechanism that is driving the ram, which is holding the tool here, and it is moving in a to and fro reciprocation. And this is the vise on which the workpiece is being held. So this particular image is of a shaper. On the other hand, if this arrangement is applied onto the work table while the tool remains stationary, that would be referred to as the planer. But now, since we've talked about so many similarities, it is also very important to know about the differences between shaping and planing. So let us take a look at the differences now. So shaping, well, the workpiece is held stationary while the tool is reciprocated, while in planing the tool remains stationary while the workpiece is reciprocated. And in case of shaping, the quick return mechanism is integrated with the ram. In case of planing, the quick return mechanism is integrated with the workpiece. In case of shaping, the workpiece imparts the feed motion, while in case of planing, the tool imparts the feed motion. And shaper is traditionally a small machine which is preferred for smaller jobs, so that's a very important difference here, while the planer is a large machine and it is preferred for larger jobs. So these are the basic differences between shaping and planing processes. Next we come to broaching. Now broaching is another very important but very specific process where a tool called as broach is used. So you can see here this is a broach and it has multiple cutting teeth, as you can see, and they are all arranged in series. So it performs multiple cutting actions in one go. Here you can see 1, 2, 3, 4. So these 4 teeth are performing cutting at different depths. So this is the broaching process, and there are two types of broaching. It can be linear or rotary. In linear broaching, which is more common, so it is much more common as compared to the rotary one, the broach is run linearly against a surface of the workpiece to perform or to produce the cut. And the linear broaches are used in a broaching machine that is also shortened to a broach in some of the cases. On the other hand, a rotary broach is the process where the broach is rotated and pressed into the workpiece, and it is used for cutting an axisymmetric shape. So that is a rotary broach process. And in both processes, the cut is performed in one pass. So this is the most important thing to note here. The cutting is performed in one single pass. If you had to cut it from this step to this step, you might have used a milling cutter to perform the same thing, or some other process like shaping or planing. But in this case, you are performing all these multiple cuts in one single go, and that improves the efficiency of the broaching process. So here you can see how the broaching process works here. A tool is pushed into the workpiece wherever the slot or the shape is to be made, and you can see the size of the broach, the multiple teeth that are being used, and how the cut is being progressed. So these are the different types and shapes of broaches which are available. So in case you're using a linear broach, it would have a shape like this, or it would have a shape like this, like these ones. But a multiple or a rotary broach, you can make an axisymmetric shape like this, or even this. So you can use different types of broaches. Now, about the geometry of the broach cutter. So the broach cutter, it can be seen very clearly here that the broach cutter is used for making multiple cuts in a single go. So here you can see the broaching tool. It has these teeth, and they are rising as we are progressing towards one rear end of the broach. And there's a slot here to hold it onto the cutting machine. Then you have a certain angle of these teeth, which is referred to here as gamma, which is the back off or clearance angle. So it is a very important angle that is maintained here. And then there's a short thickness between the two teeth which are here, and then the distance between the two consecutive teeth cutting points is called as the pitch, while the D, which is the depth, is the total depth of the teeth from the top till the bottom. Then L is basically the land, so the land behind the cutting edge. So this is your L, the land which is existing behind the cutting edge. Then there's another angle which is called as alpha, and this alpha is called the hook or the rake angle. So this is the angle that your teeth is making with the perpendicular. So this is your alpha. And here you can see a broach that is being used to cut a slot or a keyway here. So this is how the broach works. Next we come to hobbing process. Now this is probably the last cutting method that we'll be discussing in conventional cutting before we start with non-conventional cutting. So hobbing is a process that is primarily used for gear cutting or spline cutting or even cutting sprockets. And the machine that is used is called as a hobbing machine, while the cutting tool that is used is called as a hob. So here you can see this is a hob, and you can see it's a very complexly manufactured tool. It has got multiple teeth, it is rotating on a certain axis, and therefore it is cutting these teeth on the gear. So hobbing is relatively fast and inexpensive when compared to most other gear forming processes, and is used for a broad range of parts and quantities. And hobbing is especially common for spur gear or helical gear manufacturing. So this is something to note here, that it is mostly used for spur or helical gear manufacturing. And hob, as we are talking about hobbing, so hob, the tool that is used here, again you can see it's a very, very complex tool. You can imagine the cost of manufacturing such a complex tool. And it is a cylindrical shape and a series of teeth which are arranged in helical order. And these teeth are fed against a gear blank, and they result in the gear teeth forming. And the hob comes in a different module: diameter, accuracy, and material range and is selected based on the specs of a gear which is to be produced. And there are different types of hobs like the involute spine hob, the single thread involute hob, then the worm gear hob, sprocket hob, straight key hob, and the shank hobs. So according to the part which is to be manufactured, the hob is named as per. And if a single teeth of a hob is cut cross-sectionally, its shape is the same as the type of helical gear that it would be making. So the shape of these teeth of the hob, they decide the shape of the gear that is to be manufactured. Now, hobbing machines, which are generally numerically controlled with a computer program. So you can see again there's a flat disc here, and this is a hobbing cutter. So by the time you will end the process, this disc would have the teeth, which will be shaped on the basis of the teeth on this hob. And these machines, they come in different sizes and are motor driven, and they have a setup of 2 rotating splines, out of which one carries the hob while the other carries the gear blind. So there are 2 rotating parts on the hobbing machine. One part, it rotates the workpiece in one axis, while the other part, it rotates the cutter in the other axis. And the rotating speed and the axis of both splines are variable, which is provided to produce different types of gears. So it does not always have to be a 90 degrees. It can have different angles. And other than rotating speeds and axis variation, spindles can move axially as well as across axis. And this whole setup allows a wide range of manufacturing possibilities. So this is all about your conventional machining methods. We have discussed turning, we have discussed milling, drilling, grinding, other abrasive processes. Then we've also talked about boring, shaping, planing, and then finally we've concluded by talking about broaching and hobbing. So in the coming lecture, we'll be discussing about the basic differences between conventional and non-conventional machining.